All right, let's jump right in. Welcome to today's Explainer, where we're digging into the rigorous, peer-reviewed science behind what researchers are actually calling nature's most powerful anti-aging molecule. I'm talking about astaxanthin. Forget the latest superficial beauty fads, Today, we're looking at hard chemistry, cellular biology, and clinical dermatology to really understand how this compound works from the inside out.
Okay, I want to hit you with a number right out of the gate, 65. The literature shows astaxanthin is literally 65 times more potent than vitamin C at scavenging free radicals. I mean, let that sink in for a second. We all know and love vitamin C in our skincare routines, but chemically speaking, we are dealing with a completely different weight class here.
So here's our roadmap for today. First, nature's most potent antioxidant. Second, the molecular lightning rod. Third, defending the cell membrane. Fourth, shielding against skin photoaging. And finally, fifth, clinical proof for skin beauty.
Let's start with Section 1, nature's most potent antioxidant, a bioactive marvel.
Take a look at how astaxanthin completely separates itself from the rest of the pack here. Familiar names like lycopene and beta-carotene are just these simple hydrocarbon chains, but astaxanthin, down at the bottom there, has distinct oxygenated groups, hydroxyl and ketone functional groups to be exact, at both ends. It's actually the pigment that gives salmon and lobster their reddish color, but for research purposes, it's primarily sourced from a microscopic algae called Heminococcus pluvialis.
Moving to Section 2, the molecular lightning rod, chemistry of a pure antioxidant.
Let me geographically map out this molecule for you because it's fascinating. At the ends, you have those polar ion rings containing the oxygen we just talked about. But right in the middle, you have this incredibly long non-polar chain of conjugated carbon double bonds. This alternating single and double bond structure acts literally like a molecular lightning rod. It can safely absorb high-energy electrons from dangerous free radicals and just delocalize or completely disperse that energy along its carbon chain.
And this brilliantly illustrates a really vital concept in biochemistry. Astaxanthin is a pure antioxidant. When it absorbs radical energy, it neutralizes it without being destroyed itself, and crucially, without ever converting into a pro-oxidant. Other carotenoids like beta-carotene and lycopene, they can actually become harmful pro-oxidants under high oxidative stress, or they can even disrupt the packing of your cell membranes. Astaxanthin absolutely doesn't do that.
All right, Section 3, defending the cell membrane, the transmembrane shield.
This is probably the coolest takeaway of our whole biological journey today. Our cell membranes are bilayers, right? They have a water-loving, polar outside and a fat-loving, non-polar inside. Well, because astaxanthin has that exact polar, non-polar, polar layout we just looked at, it inserts itself perfectly across the entire width of the cell membrane, like a puzzle piece. It anchors its polar ends at the membrane surfaces and stretches its lightning rod middle right through the vulnerable lipid center. This means it's intercepting reactive oxygen species both inside and outside the cell simultaneously.
This exact transmembrane alignment creates a profound cellular defense. It preserves the membrane structure and stops harmful lipid peroxidation right in its tracks. But amazingly, it also protects the double membranes of our mitochondria. Now, mitochondria generate our cellular energy, but they also produce a lot of endogenous oxygen radicals as a byproduct. Think of it like cellular exhaust. Astaxanthin protects the mitochondria from their own exhaust, conserving their antioxidant capacity and actually increasing their energy production efficiency. It's a real game changer.
So that is some seriously fascinating biochemistry, but it begs a highly practical question for us. Does this microscopic cellular shield actually translate to macroscopic beauty? I mean, it's great if our cells are happy, but do we actually look any different when we look in the mirror?
That brings us to Section 4, shielding against skin photoaging, the anti-aging mechanisms.
According to the research, astaxanthin mounts a multi-layered defense against photoaging. Step 1, it directly blocks a certain amount of UV radiation. Step 2, it neutralizes the resulting cascade of free radicals triggered by that UV light. But Step 3 is where the real anti-aging magic happens. UV light triggers an enzyme called MMP1, which literally eats your dermal matrix. It destroys collagen and elastin to cause wrinkles and sagging. Astaxanthin actively inhibits the induction of MMP1. It stops that collagen breakdown right at the source. To put the sheer strength of this protection into perspective, I really want to highlight a landmark study by Savour and colleagues. They found that in preventing UV light-induced oxidative stress, astaxanthin is 100 times stronger than beta-carotene. And get this, it is a staggering 1,000 times stronger than lutein. It is quite simply in a league of its own when it comes to photoprotection.
Finally, Section 5, Clinical Proof for Skin Beauty, Methodology and Results. Let's look at the actual human methodology from the Tominaga clinical trials. In Trial 1, researchers administered 6 milligrams of oral astaxanthin daily, alongside a 2 milliliter topical application to 38 healthy females. The result? Measurable, peer-reviewed improvements across literally every single layer of the human skin. We're talking the corneocyte, the epidermis, the basal layer, and the deep dermis. Then, Trial 2 was a 16-week placebo-controlled study with 65 females. It proved that taking just 6 or 12 milligrams orally actively prevented age-related skin degradation and preserved skin conditions against environmental exposure. And the animal models back this up perfectly too. A study by Komatsu et al. Looked at hairless mice exposed to severe UV radiation. Dietary astaxanthin completely stopped the physical skin damage. It prevented transepidermal liquid loss, basically keeping the skin hydrated. It actively combated wrinkle development on the dorsal skin, and it preserved the dermal extracellular matrix. It literally stopped the skin from breaking down under a direct UV assault.
I want to pull this exact quote from the literature because I think it synthesizes everything beautifully. Astaxanthin works as an internal sunscreen of the sort since it reduces inflammation and reduces UV damage to skin cells. And honestly, the most incredible part? The literature suggests these systemic photoprotective properties can be achieved with a dietary intake of just 4 to 12 milligrams a day. That's it.
So, I'll leave you with this thought. We spend so much time and money putting serums on the outside of our faces, just hoping they penetrate deeply enough to actually work. But looking at this rigorous clinical data and seeing how this molecule physically spans your cell membranes to protect your collagen and your mitochondria? Is your current longevity routine missing the ultimate internal shield? Thanks for joining me for this explainer today. I really hope you found this structural journey into astaxanthin as fascinating as I did. Catch you next time.